paper I represent.
Okay.
Thank you. So the model we represent today is called CodeReviewer, and it's it focuses especially on the pre-training, and the model will automate the code review activities. So the paper is from FSE 22, and here is a author list. There are many authors. I didn't find image for the two primary authors, and more here. Any question?
Okay, so I just mentioned Yufan Duanan is actually, the first author is the boss of Dr. Gong. Yeah, so if you have a chance to take an internship in Microsoft Asia, and that might be the researchers you need to interact with. Is Yufan here?
Yeah, I'm here.
Okay. All right, so is there only 6 authors? I remember there's some people more, right?
1, 2, 3, 4, 5, 6, 7, 8, 9, 10.
All right. You summarize them. I see. Okay. Okay, now we can see that the NLP technique and the code analysis techniques are somehow tangle to each other. But anyway, let's move on. Yeah.
Okay. So first I will go to the abstract. So this model focuses especially on the code review process, and they claim code review is very important, and it helps view, understand, and run program, and help programmers understand the code logic. And this model is a pre-trained model for these tasks. So they have 3 key underlying tasks. They focus on both the reviewer's perspective and also the committer's perspective. So they have 3 downstream tasks. The first one is called code change quality estimation. So this is a sample I got from the online GitHub. For example, for any repository, you could view the pull request, and you go into each pull request, you can see the code difference every committer committed. So the first one is code change quality estimation. It will check whether a code difference needs a review comment, and it will also help reviewers pick the code diff trunk. And the second
So
task,
maybe I raise a question here. So how many of you have gone through the code review process in industry? Jinglian, I understand you're still working, you work in industry. So have you gone through this code review process in your own work pipeline?
very common.
Very common, right? So you play the role of the reviewers or committers?
Depends. If you have a ticket, then you commit, and others will review you.
And so you play both roles?
Yes.
Okay, so maybe ask the other questions. So I think, let me see, any of us will have industry. Yifan, have you gone through the code review process in your daily development process?
Yes.
Right, so you play both roles, reviewer and committers?
Oh, yes. Our team, I'm only a front-end engineer,
So you are the reviewers of all the front-end code
yes.
committer. Okay.
Yes.
And how do you reject those commits, or?
I give the comment and send a message to the committer.
Ask them to resubmit.
Notify, yes, to refine their code.
All right. Okay. So maybe another question is that, what kind of code will you try to reject? Is maybe sometimes it's not just buggy code, or sometimes it is not conform to certain format, or so specific reason for us to reject the code, the commit.
Most of the time is about the code style.
The code style, okay.
Yes.
And how about Jinglian? What kind of code will you try to reject?
If the logic is bad.
Okay, so but how do you define bad?
I mean, depends on your ticket requirement.
All right. So, but when you're giving a ticket, it is whose responsibility to write the test cases for certain tickets, or there's no protection of the test cases?
the committer should have the responsibility to make
provide
sure.
the test cases. It's not the one who issued the ticket.
Yeah.
So in that so I'm not sure it is appropriate, but why don't we ask other people to write a ticket and the people? So just like the one, if the programmers or developers who it is the programmers and developers who provide the tickets or to provide the test cases, isn't that a bit weird? Just like we give you a questions and I should have the answer and you provide I should have the test, you provide the answer. If your answer can pass my test, that's okay.
That's right. That's
so why in your companies you ask the developers and programmers to write the test cases?
I misunderstood because usually QA will open the ticket and they define what's the expected result, but they usually just use descriptions. So you need to translate that description to test case in code. Yeah.
It is very interesting. So how details, sorry, I just a little bit over the topic, but it's reading the question and the descriptions, the information really interests me. So my next question is how details the QA need to provide the requirement?
Very detailed, like what's the expected behavior in your UI or in your behavior? What do you block? What you don't?
If it is so detailed, why don't they write the test case by themselves instead of using the natural language description?
They don't have coding background.
I see. So they may not the people from computer science.
Yes.
I see. Yeah, maybe we can talk more offline. Okay, let's move on. Oh, by the way, is there any questions? I encourage every of us raise some kind of questions. I think especially for the PhD student, on raising questions is some of your work, some of your research work. Okay.
Yeah. So the second downstream task is review comment generation. So it will generate a natural language for the comment. And the third downstream task is called code refinement. It's based on previous code and the comment and generate the refined version of the code. And they also created a benchmark data set with 9 programming languages with all this pull request information.
So okay, so maybe let me summarize a little bit. So it seems to me it is the first one is a classification or regression problem,
yes.
Right? And the second one is about the generative problem. So they want to generate comments.
Yes.
And the third one is more like a code modification task. So which means that given the reviewers' comments, they're trying to generate the modifications on the code.
I feel the third is also like generative task.
But it's called code refinement. So what is the input of the third task?
Previous code and the comment.
Yeah, the previous code and comment. So the recommendation is a modification instead of the code, right?
No, they output the code.
They output the code.
Yes.
All right. So yeah, it seems a little bit different. So there's a technique called code repair. I'm not sure whether you heard about it. The idea that given the code, and now it is unsatisfactory, and the program is trying to modify the code so that the code will become satisfactory. The definition of satisfaction means that it can pass certain test cases. So I'm not sure how the two tasks can kind of resemble it. Yeah, but it might be, I think Chen Hing is not here today, but basically he is working on a technique on the code refinement or the code mutation. All right, so any questions for the task here? I think this is very clear now. But I will try to ask someone to repeat the 3 tasks, maybe 2 slides away. Okay, if there's no questions, let's move on.
So the model is a traditional encoder-decoder transformer-based model. And they have 4 pre-training tasks. And that's what they called novel in this paper. And the 4 pre-training tasks are important for the code change understanding and generation. So they have 4 tasks. I will give details later. So the 4 tasks are diff tag prediction, that is predict what should be the label of your code during your change. Is it an add or it's a minus? And the second is denoising code difference. The third is called denoising review comments. And last one is the review comment generation. I can give details later.
Yeah, so I have so many questions based on those pre-trained tasks. So maybe we'll move on. Let's move on. Yeah.
Yeah. So firstly, they still define what is the code review process in simples, and they still first talk about the 3 downstream tasks. So for code review, basically you have a D for the code change, and C0 is original code, and C1 is the committer's updated code version. Then other reviewers, PR, will review and give the comments. RNL, I think it's natural language. And based on the comments, also will give a newer version of code C2. And maybe this process will repeat it for a few rounds, and finally pull requests will be approved, merged, or discarded. And just like Prof. Lin just talked, the first downstream task is a binary classification task. You have the code change, and you just predict whether its quality is high or it's low. So your input is the code change difference. And then for the second code review generation, your output is a generative task with a list of words, and your input is the code change. And the model will generate few candidates, and reviewers could select from them. Yeah, and the last one is code refinement. They give a refined version of the code C2, and their input is the original C1 and the R natural language. And for all the D here, their data format is called diff hunc. So each line, it will have plus or minus sign at the beginning, or if it's not modified, it will also be marked as keep as original. Yeah. Any question for this?
Any questions for Jinglian?
Okay, so, I'm wondering, so basically, the authors claim that the code reviewer software can perform all 3 tasks, meaning to give the estimation, to give the comments, and to generate a newer version, indeed.
Yeah, I think based on GitHub, the reviewers can give comments, and then the previous author will push some more commit and get a newer version.
Yeah, I think when looking to these problems, I just feel that I have new ideas coming in my mind. So, but on a commentary to John Yi's question, I think the third task is to replace or help the programmers or the committers, right? So the input is the comments by the reviewer, and the output is the refined version of the code. So this is a task for the committer instead of the reviewer.
What I'm thinking is that if the software gives code review comments and also provides refinement at the same time, there's no need for PR. You can just run this before PR, and it can just
by right. Yeah. So it assumes that all these tasks has been perfectly finished. There's no human intervention at all. But the problem is that I think there must be some human intervention, or we need to put some human in the loop to finalize the whole process.
Oh, okay.
My expectation is that given a code difference, and it will generate a code comments, or basically the reviewer's comments, right? So if it is very high qualities, we just accepted the pull request. If not, we ask the committers to resubmit the code. And once for the second stage, which means that we need to leave some comments, maybe the AI just provide a template or just provide a skeleton, and some of the humans do need to input some of his own comments, his or her comments, to finalize the stage, finalize the problem.
Okay, I see. Yeah, I agree that if there's human intervention like still needed in this process, then it is justifiable that it only performs the task on submitted PRs. Else, I really don't see why we need a PR to perform these tasks. We can just maybe compare to maybe Sonar or Lint, we can just run locally.
So
and
you know about Sonar.
yeah, I use Sonar for some projects.
So Morgan, no, sorry, you're in your internship is in which company?
Yeah, in JP Morgan, but
In Morgan, yeah, in JP Morgan. So JP Morgan using Sonar to detect quality, code quality.
it's team specific. I cannot say that it's a firm-wide practice. It's just my team. Yeah.
So does the bad smell reported by Sonar inside of 4 or help 4 in your code quality?
I think so. It's like it can give your suggestions on whether you should try with resource instead of just try. And when it finds some code duplications, it can also suggest to merge them or abstract them into a new function. But I think that to do this simple like modifications, there's no need for a PR, and submit PR is extra effort on top of it.
Yeah, I think this is more like automated rules, right? So they can detect the duplication, the code duplications. They can detect the code bad smells.
Yeah.
But sometimes we need a more refined or more high-level instructions. For example, there's a requirement, and just like Jinglian once mentioned, whether the implementation really faithfully implement the requirement, it is not quite sure. And in this case, it may out of the reach of the Sonar to address this problem.
Okay, yeah. I think we can find out later what's what
yeah
on top of Sonar.
Okay, so maybe I make a minor summary here. Basically, Zhang Yi is telling us that, so given this process, whether there's a way to fully automate the process, especially there's a tool called Sonar. Sonar is a tool which can help to scan the whole project and report the code quality. For example, where there's a duplicated code, which means that we need to do some refactoring, or whether there's some maybe overlong method or overlong class, which means that we need to decouple the code. So with that information, with this reported bad smells, the developers can refine the code by themselves instead of looking to the reviewers' comments. But the discussion, or we conclude that once there is some high-level requirements, and so that may not be sufficient. And also, if this process can be perfect, which means that the AI model can make the recommendation with 100% accuracy, maybe this review process can be fully automated. But in general, we believe that a human-in-the-loop solution might be the most practical way to go. Okay, Jinglian, maybe you can move on.
So firstly, they talk about how they construct the data set. They created a very large data set. So they select 10,000 projects from GitHub with 9 programming languages. They keep only those with permitted license, and they remove out all projects with less than 1.5K per request. And then they use REST API because GitHub support all this. They use REST API to get all data in JSON format. And they especially talk about this framework infrastructure to do all the REST API easily. And so they first collect meta information of the pull requests and comments, and they get the git commit hash and the change file name and all the related comments. So the first 2%.
Yeah, any questions for this process? So this is about the experimental setting. Yeah, so I encourage especially the PhD student who can raise a question. You want to find something strange and you want to find something curious, and you propose your question. All right, maybe I raise one question. Why MIT license matters?
Because they allow redistribution of the data.
So it's for legal consent.
Yeah.
Okay. Yeah, I learned the news that now there's you're not Copilot, right? The Copilot is on, I think Yufan now this quite well. Yufan here? Okay, Yufan still here. So for this Copilot, it is now facing some lawsuit, or giving the Copilot is it's released. Some companies, especially some industry, so the commercial company, they're trying to quit GitHub. So they don't want to put their source code even on GitHub, even in the form of private repository, because they find that when the GitHub is when the compiler is trying to recommend the code, they are recommending the code from their repository, and their repository is basically commercial. So in giving this view, these commercial companies trying to quit their projects on GitHub. So this is some legal issues faced by this AI-based model. All right, okay, let's move on.
And then for the data construction, let me see. Still some filters. So they only consider change with comments that what's here? So they remove some suspicious comments, and then a change. Sorry again. So they think the change with comments are suspicious, so they are bad in terms of quality, and those change without comments are good. And because the change without comments has a large number, they are 3 times more than those changes with comments. So they randomly downsample those good comments and they give a balanced data set. That's the data set for
And have they mentioned that how they believe comments are suspicious or wrong comments?
just those change with comments.
Sorry, so what do you mean by change with comments?
For example, you have a comments next to your change.
They're only looking to the comments on change, right? Instead on code.
Yes.
Okay.
And then for the review comment generation, they filter out comments written by the change author. And when there are more than one comments based on the deep hunk, they only keep the earliest one.
Oh, sorry, I have a question here. So I just don't understand why they only keep the earliest. Because I think in a real situation, the later comments always describe different problems, or it's a supplement to the previous. So I think the later comments is also important. So
I think because the first comment describes the problem, then later comes with discussions. So there are many noise in the discussion, like talking about other environment things. That's my feeling.
Yeah, another reason is that the AI would like to ask the right question, right? So maybe the AI technique will be serve as a conversation robot, so they can interact with committers back and forth for a while. But I think for this research, they just want to, for their current task, they just want to ask the first question, right? See, this is a current task. But in the future, but I think there's a talk given by Professor Chada-san. It is basically talking about, I think it is about interactive recommendation. But in their settings, they're talking about the shopping. So if you want to buy a shirt, you want to buy a pants. So if you just give me a description, so it is very general, it is very rough. So the AI system may not well recommend your favorite one. So a technique is that they would like to guess what you might like and then provide several options and try to take the feedback on to construct a conversation with the buyers and with the one who proposing the request. And by these back and forth conversations, they try to refine what they really want. maybe the idea can also apply to here. So once the reviewer provides something general, and maybe the committers we can have some interactive conversation technique here, but that is a long-term vision. For now, we can just look into the first, I think we can look into the first questions. Yeah.
Okay, I see.
Then for the code refinement, they traverse each pull request and check all the commits. And if there is a later commit that update that part again, they collect a triplet, the original code, the comments, and the updated code. And they think they have many unconsidered cases. For example, one comment is related to multiple future code revisions, or multiple comments contribute a single revision, but they are non-considered in this paper. And more details in the appendix. And then for their data split, they split in project level. So they mentioned that repository with more than 2.5K pull requests are pre-trained dataset. And those repositories with this number of pull requests are validation and test.
Huh? Why do we split like this? Is there rationale for using large repositories to train and smaller ones to test?
Not in the paper.
Oh, okay. Curious.
Yeah.
Sorry, could you please go to the previous slide? I want to check once. Yeah, can I ask how they choose these projects? Whether they choose the GitHub, I mean the stars or forks with large numbers, or just random?
They just said top 10K. I'm not sure.
Oh, so that means they indeed consider some such situation. That means they will choose the high quality.
Yeah, I think so.
Another question, maybe Problem can also help. I just wonder why they need to, define tasks for pre-train and then test the pre-trained model on other different downstream tasks.
Yeah, so I'm not sure I fully grasped what it really means. So the idea is that they want to support 3 tasks. Maybe I try to ask Yufan. Yufan, do you remember the 3 tasks Jinglian talked about? Hello, Yufan.
Yes.
Okay, could you remind us, so which 3 tasks?
First is the quality estimation. Second is
The cost estimation for what?
For the code difference.
For the code difference.
Not the code difference. For the what?
Maybe Jinglian can remind you, Yufan.
The deferred code. Yeah, that's.
You mean the code, the quality, right? So it is more like the commitment, right?
Yeah, whether the difference needs some comment or not.
Okay.
Yeah, the second is the review generation, and then the code refinement.
All right. Okay. So maybe let me continue. So I think the pre-trained model is based on for these 3 tasks. So in this case, they assume, I guess that it will be proposed. They propose a general backbone network, which can provide these 3 tasks, such as a downstream task. So I'm not sure whether I'm answering your question.
I remember they also define 4 for pre-training, right? I'm not sure.
For what?
For tasks.
4 tasks, 3 tasks, or?
Jinglian, could you please go to
yeah,
slide? I remember 4 tasks for pre-train.
There are 4 tasks.
Yeah.
All right. Okay, got it.
This is my question. Why, if I want to do the 3 downstream tasks, why not just use the data set of 3 of these tasks? Of course, when validation or test, we use different data set, right? But why use different tasks for pre-training and downstream?
So I can try to answer it with my understanding, but before I give my answer, Jinglian, would you please address this question?
I feel in history, NLP, like there is a trend here. So they have different tasks. They have very general tasks for pre-training. For example, transformers, their pre-training are just like feeding the code, but then they have different downstream tasks. For example, even it's different from the pre-train task. Your downstream can be code generation or be code classification. So so your pre-training just like give a common sense about all the data and the environment. Then you downstream.
My take is that this is different from the traditional task that the input is code. Here the input is code change, right? So in this case, they require, so just like Jinglian mentioned, so the training data for these the downstream tasks is not large, right? So in this case, I assume that author would like some code change based pre-training task. And if these four pre-training tasks is more convenient for us to collect the code change based sample.
So Jinglian, maybe a question for later side. Did they compare the such kind of pre-trained tasks when it will influence? For example, if I just use the similar tasks used for code board, for example, when it matters a lot.
They do discuss about the influence of these four pre-training tasks, but it didn't compare with the code bird. They just compare what your model output is like with all four tasks and what is the output without, for example,
more like ablation task, right? Ablation studies.
I just feel a little bit.
But
so what I'm interested here is that, so given the code is very straightforward, that we can using the code bird in a very straightforward way. But for this code difference, so how to embed or how to encode the code difference, right? Code difference have the addition, have the removal, and have the replacement, and have additions, and how to encode these kind of the code change features, and also whether we need to take the context of the code change as well. So that is also my questions.
Okay.
Then we can talk about the model details. Like their model is the same architecture as what they call the T5 model, and it has encoder with 12 layers and decoder with 12 layers, and 12 attention heads in each layer with this number of dimensions. And we still like have three downstream tasks, right? So for the code estimation task and code comment generation task, their inputs are the diff hunk, and the refinement task, their input is original code with comments. And they use the roboter.
Sorry, for here, the input are diff. So given a code change, they may contain multiple diffs, right?
Yes.
And they will take all of them into account?
Yes. I don't get what do you mean by all, like multiple.
Which means that the user will have a commit, and this commit may include 100 changes, and each change may take maybe several lines, right? So which means that they're not just so they is, and how do they represent it in the model?
I think they only consider one change in one part when they are next to each other.
All right, so which means that they're looking to the individual diff hunk.
Yes.
The input is an individual diff hunk instead of several hunks. Okay.
Yes. So they still use this CRS tag in front of input source codes, and they use these two tags for the
deletion additions.
Yes. And they use this tag before each unchanged lines.
Okay, maybe I ask questions to Yufan. Yufan still there? Hello, Yufan. Okay, Yufan maybe go to toilet. So maybe Xiangling, are you still listening?
Oh, yeah.
Yeah, so maybe a questions, I try to raise your questions. So we're talking about if there's a difference, the difference we can delete some code, we can add some code, or maybe we want to add some code, right? So in these Robota tokenizers, they only looking to deletion and additions. And what do you think, how do we represent the replacement or an addition? The edit.
Edit.
Yeah, edit means that we just modify the
edit.
code. Or modification.
You mean
How to represent. So we're talking about the model. Now we're not taking the code or not taking a sequence of tokens as input. We're talking about the code difference, right? And the code difference will have additional text like deletions and additions. But how do we modify, how do we represent the modification?
So add tokens here.
Huh?
I'm not sure.
Or
what does
Jinglian,
mean.
or yeah, so we're talking about when they have different hunks. If you look into the Git diff, if you have ever used the Git diff, you'll find there are several additions and several deletions, right? So, but how do we represent the modification? Modification is still part of the modification is that the code is there. I just need to modify one token. For example, I changed the variable A to variable B, right? So how do we represent this kind of change?
Delete first and then
Yeah, it's
insert.
first delete and then-
All right. Okay, so which means, but if we look into the Git diff, suppose there's a very long sentence or there's a very long line, a line of code, even if we just want to modify one tokens in a line. So we just need to put everything into the input, right? Okay.
And for this, they use this MSG tag between the code and the review comment for this task. And their output for classification task, the quality one, they classify based on the CRS tag. And the other two are sequence generation tasks. They use the decoder output. And yeah, they before they really fine tune the downstream task, they do the 4 pre-training tasks in total. Yeah.
Excuse me, did they explain the input and output of the pre-training task?
Yeah, in next.
Okay, sorry.
Yeah. So the first one is called deep tag prediction. So still your input are the diff hunk, and then your add, delete, keep labels are masked. So your model gives probability of these 3 models, and then they use a cross entropy loss to further train the model. Is that straightforward? And then this is the first task. And the second task is called denoising objective. They said it's previously introduced and popularly used in natural language programming. And this task is to get a general understanding of the corpus. So in the very original idea, these people initially randomly mask words in input sentence and with a corrupted rate of, like, for example, 50%, and then they predict what are these words. And in this model, they have 2 types. The first one is called denoising code diff, DCD, and the second one is called denoising review comment. So denoising code diff, they randomly select 50% of code lines and mask them. So this is a line level corruption. So they want to keep the integrity format of the code diff. And then they still keep these 3 tags, and they just mask the line, and the model will try to predict what are the line, the code change. So DCD helps the model generate better source code in the code refinement task. and still the loss is you have masked codes, and you try to predict what are the masked code, and you try to train the model. And for DCR, this is on the review comment. So this is based on natural language. So they corrupt the review comment as input, and the model needs to recover what is the masked word. So they randomly mask spans with 20% of corrupted rate, and they hope this pre-training task will benefit the comment related tasks. Any question for that?
This may be related to the background knowledge. I don't get how the denoising process can help to achieve, like how does DCD helps to achieve better generation of source code, and how does DCR benefits a comment related task? Like, what is a overarching idea for denoising?
It's just like you have some environment code, then you try to guess what is the missing code there. So you kind of like get the overall sense of the code, the overall code corpus.
And this idea looks very similar to BERT. So I'm not sure, Zhang Yi, you're familiar with the BERT model. So the BERT model, when we train the BERT model and input just a sentence, they're using some task called a masking language model. So they randomly mark certain token, and they try to ask the BERT model to predict what has been masked. I think this is a way to force the model to learn the language model in these settings. For example, so giving a sentence or giving the input, the former is a code difference and the latter is code review, right? So they're trying to build the connections between, they try to capture the language model of this format of the language, right? So language is in code. So basically that's just a model trying to learn that, to see how natural the model is fitting to the overall language distribution.
Okay, and it is proven that this starts improves that the performance, right? Like it's like established.
Sorry, what do you mean by garbage?
It's established that.
Established. Okay, yeah.
Concept and
Exactly. Yeah, but I just have a little bit concerned about the noisy. So why it called it denoise? Denoise means that it's a noise, and we want to remove this noise, so it's called denoise. But why it's called denoising objective?
I don't know why they call this.
Yeah, this is more like a standard measures to train a bird-like model, right? So now we have a new kind of languages, and we do something similar to what bird do. Hello, Xiangling, you are raising question? No. Okay.
Sorry, can I ask a question? I forgot what's the input and output for the DTP input for the DTP.
Codes.
Input is code.
I think the both code and the comments, right? Do they require the comments or no need, right? Okay. Oh yeah, no need, right?
E are the debunk.
Yeah. Okay.
So the code, then they predict the
label.
Oh, by the way, what is keep?
Keep is unchanged lines. For example,
I got it. So which means, right? I see. So is that reliable? Is that reliable? So
is sorry, I still confused. The input is code change or code?
I think the code. I think both code and code change. So since there's a keep, so they're looking to code, and definitely the context of code change. They're looking to code change, but definitely the context of code change will not be changed, right? So in this case, you want to predict which code has been actually changed by addition, deletions, and what code has not been changed by tagging the keep.
That means two code.
Yeah, I think they definitely include some comments. So, sorry, not comments, including the context.
But I mean the code before change and the code after change.
Maybe the code the
No.
no code change as well. So here you can see the
Mm.
code change has been fully modeled as code, but the code with addition and deletion label, right?
Oh, with the label.
Right. So as long as given a code without any label, and the model would like to learn what code, which line code or what tokens are actually the deletion tokens or addition tokens, or the token without any change. So that's basically my understanding. Jinglian can correct me if I'm wrong.
I think that's right. You have four, for example, 4 lines of code, and before each line you have a masked label. Then you try to predict what's the label.
Okay, I see. Thank you.
So that's the 3 tasks. So the first task give you an idea about the code and its label. The second one is idea about code and code. The third one is idea about comment and comment. So they have a 4th pre-training task, that is a review comment generation. So they feel this is the most challenging part because it captures the relationship between code, comment, and then the review comment. So they use some bimodal data. They have both code change and natural language, and they call this RCG. So your input is a code, and the generated comment so far, and then you predict what.
So the question is, the code change is for where do they get a comment? Still from the reviewer comments in the pull request.
I think so.
Yeah, but I think there's other sources, like given a change, given a commit, there's a commit message, right?
Yes.
So by right, there's also another source of comments, but it's more like abstract comments. If we look into pull request, that are more detailed.
I think they didn't consider the commit message.
Yeah, I got it. So just look into the pull request.
So there is some example. This is the first task. You predict what's the label of each code change, and the second one you predict the code line, and the third one you try to predict some code, the comment, and the fourth one your input are code and the original already generated comment. And you just try to give more the following comment.
Which one is the fourth?
Fourth here.
This fourth. Okay. But for the fourth task, what is the scalability of the data? So is that the data larger? So just for definitely the first 3 tasks are the most. I think the first task has abundant data, right? But the second, the third, and the fourth have limited data, right?
From their own data set.
Yeah. So if they want to collect the reviewer data is much less than the just code change data, right?
Yes.
So which means that the data used to train the first task is much more abundant than the rest 3.
I think yes.
And giving the data imbalance, do they specify how they train the model?
No.
All right.
They didn't say how many epochs or what's the data set.
Okay. Yufan, do you have any question? So, okay, so maybe you can think about one question to ask. Yeah.
Can I ask a question?
Okay.
What's the difference between the fourth pre-training, fourth pre-training task and the second downstream task?
The second downstream task.
I remember it's also review generation.
Yeah, you generate the comment based on the code difference. I think it's very similar.
Probably. What do you think? Why?
I don't have the specific answers, but maybe we look into different hunks or so both. I think the fourth pre-train task and the second task, the second learning task are are all looking to individual debunk?
Yes,
Or okay, so so is there exactly the same?
I feel it's the same.
Okay.
Oh, okay.
So if they're exactly the same, when they do the experiment, this will be a little bit tricky, right?
Mm.
So the training, so how they prepare the data set for the pre-trained task, and whether the model favor the second task instead of the third or the first. Because the data has been trained for, the data for the second task has been trained for multiple times.
They definitely will use different data set, but the task is the same.
So definitely will favor, right? So they will favor because so the second task is also one of the pre-trained, is also one of the pre-training tasks.
Yeah, I think so. But it depends. Yeah, maybe let's keep this question and let's see the results.
But you don't compare the second task with the first and the third downstream task because they
But
are,
we can see their performance, right?
yeah. Then we comes to the study. So they have 5 questions. The first 3 are just what's their performance on the 3 downstream tasks. And the first one is how does each pre-tasks play in the code reviewer. And lastly, they talk about multilingual data sets, if multilingual data set will benefit the performance. Yeah. So the first one is that you remember the classification. So they compare their code reviewer with the 3 base models. So the transformer is just a SOTA for all general classification and generation tasks in ARP. And the T5, they say they pre-train denoising. They also pre-train denoising objective on their own data set. And their own data set are from Stack Overflow or Code SearchNet. And this code T5 is the SOTA for code-related downstream tasks. So this code T5 is also pre-trained on denoising tasks. And they are saying there is improvement in the precision, recall F1, and accuracy.
Well, let me clarify. So given their design, so they, given their model design or model architecture, so this, maybe let me put the questions, rephrase the question in this way. So the 3 baseline models and this code reviewer, this their approach, and they share they share the same input and output, right?
Yeah, they design and share the same input.
Maybe I ask a question like this: what is their claimed contributions?
You predict whether the code difference is good or not.
Yeah, so they provided new applications, or they provided a new model architecture to handle this application, or both.
We knew there is no new architecture, but they have more pre-training tasks to let the model have more.
Yeah, if they just propose the pre-training tasks, we can just using the old model, right? The code bird can also be used, I guess.
Yeah.
Right. So if, and also here for this RQ1 on code reviewer actually outperform the rest ones, which means the rest ones can also be used for these tasks and applications, right?
Yeah.
But the code reviewer has the better performance, have the improvement. So the question is that how different code reviewer is from these baselines, and what the difference in terms of architecture, and what aspects of the code reviewer architecture, of the model architecture of the code reviewer is better than rest.
So we see there's no architecture difference. They also mention in their title their novel part is a pre-training tasks.
So the difference just with and without pre-training tasks.
Yeah.
Okay, the code reviewer share exactly the same architecture with the transformer or
with the T5.
With T5.
Yeah.
Okay.
I think it's the same.
Yufan? Hi, Yufan still there? Hello, Yufan.
Yes, I'm still there.
Yeah, are you familiar with the T5?
Yeah, I'm familiar with that.
So how is different? How it is different from the code BERT?
BERT is the encoder of the transformer, and the T5 is the encoder decoder architecture is different.
So which means that decoder has also be pre-trained.
Yes. So you can see that pre-trained task is a bit different.
I see.
Yeah, it's predict something, but for BERT it will not. It will concatenate all the input and use the mask language modeling.
And the T5 is still using the mask MLM task.
T5 you can use some prediction task. It's not just
which one has more enriched tasks for?
Yeah, because
by the way,
it's a decoder. Decoder
I got it. Yeah, decoder has more enriched tasks to pre-train it. I understand. So when is T5 published?
I think 2 years ago.
2020. Yeah, 2020. On which venue?
It's published by the Google, because they just based on the transformer, they see that the BERT is good, so they based on the transformer build another model. It is very large model and much larger than BERT.
Much larger than BERT. So if we want to train the T5 on our own machine, is that feasible?
Yeah, there are small versions. There have 4 versions: small, base, large, and billion version. So you can maybe use the small version.
Only small version, even the media we cannot use.
I didn't try that. Maybe base version is still okay, because I see I checked their performance. The small version is not quite good, but the base is relatively okay with large and more larger billion level. So maybe base is okay. We can use the base version.
Okay.
Actually, they just compare with different, there are several styles. The first is, I just said, the encoder or decoder or language model. There are 3 types. The first that use the encoder decoder architecture. The BERT use only the encoder, and sometimes the GPT only use the decoder or the language model. So there's 3 types. And then they also just they just check different architecture and see which one is the best. So they compare to do many experiments, and finally they find that the encoder decoder architecture gets the best performance. And there are also many ablation study, like many you needed to read.
Yeah, got it. So so you need to do that experiment and try everything. So it seems to me more like a label intensive, right? It's more label intensive.
It's just a pre-training model, so it's just the same function of the
It seems to me that the advantage more like seeing the pre-trained task is applied on both the encoder and decoder.
Yeah, so and this model can do many downstream tasks. That means you can just, for example, because it's an NLP task, if you put the input, use a prompt like translate English to German, and then you concatenate with the English sentence, then it will do the translation task. So you just add some prompt. The model can predict the result. So you don't need to fine tune it again. This is the feature of the
model, because the model have pre-trained ask as English to German translation, right?
Yeah, because the model is too large, so we don't have to fine tune it, because it's waste of time. So basically, they just use prompt to predict something.
But actually, I think we still need to have some knowledge distillations if we want to make the task specific for the code, right? So just like you mentioned, if the T5, the pre-trained task is English to German, but we want to have some code generation task, which means that the input is English comment, and we want to generate the code. So if we do not have any knowledge distillations or refinement training, what we get is not a code. Instead, we got the German language, right?
I think they just train the model from scratch because it's called T5. They use a different data set.
Definitely in these papers, the code reviewer just using a T5 structure and pre-trained with this or what described by Jinglian.
Yeah,
Yes.
yes.
Oh, hi, Jinglian. So the baselines use a different pre-training data set as CodeReviewer, is it?
I think yes. They said they with their own data set.
So is that fair?
Yeah.
But I think they use the same data set. The transformer T5 and code T5, they use the same data set with others.
I think they might be trained using the same data, using the trained data set with the tasks, but the code reviewer had the advantage of these pre-trained tasks, right?
I think they fine-tune because the transformer
Both
they needed
fine-tune,
to.
all of them fine-tune with a data set for the 3 tasks, but only the code reviewer are pre-trained with a pre-training data set, right?
Yeah.
I think it's not it's unfair if this is the case, but I think they should. Jinglian, would you check? I think they said they train on the whole data set. They're not training on the whole data set. They just fine tune.
For this, I think they just fine tune.
Okay.
And I remember this paper argues that the code reviewer is T5, right? It's based on T5. But why they use 12 layers, but T5 here use 6 layers?
Where is the 4 layers?
12 layers, I mean for code reviewer.
12 layers.
Yes, but for T5, why they only use 6 layers here? 6 layers, 12 layers.
I think they refer to this code T5.
The 6th layer is the small version of the T5.
Yeah.
So they're not exactly based on T5. They're based on code T5, right?
Yes, I think their baseline should be called T5. I think they, training their data set on the code T5, so they compare with the code T5.
But anyway, so they do not claim they made any contribution on the model architecture, right?
Yeah.
So their claim is that how they collect the data set, how they organize the pre-training, because they're not code T5 is more like a code bird, so they have their own pre-training tasks, and since code reviewer is working on code difference, so they define the way to collect the code change, and their reviewers, they define their specific code pre-trained tasks and get a new code reviewers. It seems to me that they find a very good angle and pay, at least for an idea level, they just find different angles and do almost very similar work as code T5 and code bird.
But if me, I will choose do this experiment like this. For example, for transformer, we use the let me annotate. We use this pre-train pre-train task, then we use their proposed pre-train task, then compare. If I will compare both, right?
If you want to compare both, but the idea
compare the pre-training task.
But they claim the contribution lies in their invented new pre-training task.
Yes.
Right. So basically, they just need to compare code T5 and code reviewer.
Yeah.
They just have the same. They have exactly the same code architecture, and the difference is just they have applied their invented pre-training tasks.
Yeah, but they didn't do, right? Even for
they do. So the code T5 is trained on their dataset for the 3 tasks. But they do not, the code 5 is not using the pre-training we do not apply pre-training task for code T5, or the code reviewer equals pre-training tasks plus code T5, if I understand correctly, Jinglian.
Yeah, I think yeah, you are right.
Hello?
Yeah. So what is the code T5? Who published the code T5? Is sales their team?
It seems yes. Salesforce.
Dr. Shan, any questions? Hello? Is there any question?
No.
Okay, maybe let's move on.
Yeah, so this is their result on the first downstream task. Then for the second downstream task is about the review generation task. So still they use CodeReviewer compared with these three, and they are saying the blue score of their model is lower than 10, actually all lower than 10, meaning this is a very hard task. So they involve some human evaluation. They have 1 to 5 scores for each level of how good your comment is, and they basically do their own evaluation for all the generated comments. And this is how they do the human evaluation.
And how do they recruit the participants?
Didn't say that.
No, they must say that, right? So there's the Likert score 5, right?
Yeah.
1 stands for lowest, the 5 stands for highest.
Yes.
And how many participants have they invented, and whether they will remove the lowest one and remove the highest ones that take an average. So they need to perform some procedures like this.
I think in their appendix, if you go their appendix B, they only mention their standard for 1 to 5, but they didn't say how many participants and what.
Okay.
Do you want me to go to the
No need.
Okay. And they have one qualitative analysis. They also based on the codex, the Copilot. So they are saying that from the research, Copilot can't generate any meaningful reviews, but just copying comments in the given examples. And they're saying their code reviewer is having more better comment. Even the blue score is low. Yeah.
So could that be a little bit more specific? Saying this is a debugging help.
Yeah.
And should be lower than the default visible info. I got it. So which means that this is the reason to justify why we reject the comment, why we reject the commit.
Yes. So firstly, it must be previously it must be a positive prediction on this, right? It's a bad comment, it's a bad code change. Then you try to give comments to this, right? Then you are saying why it is a bad code change, and you are saying because it shouldn't be something.
Okay. Any questions here? Especially the students working on NLP. So this is it is almost, but anyway, why it can have a good performance, it is almost black box to us.
Yes.
Okay. If no question, let's move on.
So the lastly is a code refinement task. They use a blue score and the exact match score for still the code reviewer compared with 3 baselines. And they are saying code reviewer successfully generates the repair code exactly the same as ground truth for more than 30% of the case. And the transformer didn't even converge in the fine-tune process after 10 epochs. So giving 0 blue score. And so they didn't release transformer here. So this is an example. So this is a comment. This should only happen once in initialization. So you should be moved out. and then in the refined version, in the new generated code, it is removed.
Could you could you specify what is the input? The input is code change for the first commit in the first commit.
Yes, the input is a comment and the original code.
Original code.
Yeah.
And the code change is not taken into account.
Yeah. Yes. Right. If we go to previous, where is it? The original code, the first version of the code, the comments, and you give a second version of the code. You don't consider the diff hunk.
I see. All right. Okay. So I have no further question.
Yeah, I think until now, it seems the model didn't favor the second task, right? Do you remember we mentioned the fourth pre-training task is the same with the second downstream task?
Those examples kind of a cherry pick. So they find the best one generated of it. Very hard to say. There's no favor.
Yeah, but my point is the blue score is very low, right?
Yeah.
Yes. Yeah. So yeah. But you can see there's almost 20% higher than the baseline, right? In terms of blue score.
Okay. Yeah.
Right. So if you consider the ratio.
But the code X is the best.
The blue score is high, but they say the from rational.
But you can't say when you compare, you should compare the blue score, I think.
But they do not put code X in the table, right? Even if it is have a higher score. So they can see that's a little bit tricky when they're writing the paper. When you have in the blue score there, so by right, I just guess that if we're using code X, if we put in the table and the blue score of the code reviewer will not be higher than anymore. So, but anyway, so they have a justification that why the code X should not put in the table, and they provided an example saying that why the blue score is not so justified to.
But then they put the blue score to compare with transformer and T5.
Yeah, because they can outperform them. So I just have a speculation, but it may not be true. All right, so here, Jinglian, so my last question for these slides is that for the code reviewer, so for the third task in code reviewer, the input will still start with code change, no, with the code as the former part and with the comments and the later part, and the T5 structure generate code accordingly, right?
For the third task, yes.
Okay, so but for these three tasks, they train the code reviewer model with different weights. For example, they have three tasks. So given these three tasks share the same pre-training tasks, but if we want to have the model for three tasks, if we have the model for three tasks, we have individual models, right?
Oh no, because it's T5. T5 can generate.
I mean the fine train.
No need to fine tune.
No, the fine train will have the different loss function, right?
I think I just mentioned that T5 can use a prompt to generate anything.
Yes,
so they don't
T5 can do this. But the point is that, for example, the first task is the binary classification. And the second task is basically reviewer generation. And the third task is code generation.
Yeah, it's all so that no.
And in addition, the third task even have a different input than the first and the second one.
Yeah, but from T5 they should have no new fine tune. No, there are no downstream tasks. No, that is thinking, I think.
Really?
Yeah, I think they use one model for all three downstream tasks.
One model for all three down.
Yeah, they use one model, but for classification, you use CRS to predict, and for generation, you still use the same decoder. to do that. I think I'm not too sure. Yeah.
So you say add another.
Even the second task and the second and third task have different input and output.
Yeah. Even they had different output, but they use the same model.
Which means that T5 is really large.
Yeah.
Right, almost serve the same functionality of GPT-3.
If larger, I think it's like yes, it's quite the same. Large,
The same scalability.
size. Yes, the same size. Maybe T5 is more large because it has more larger ones, billion size.
Yes.
They basically they say they can you can just use a prompt. You can say use this to the model. You translate your classification. So you just talk to the model, and the model will generate the corresponding results. You don't need to fine tune it again.
It worries me, but the experiment is used. Anyway, the experiment speak louder than words. Okay, let's move on.
Then for the fourth study, they do the application study on each pre-trained task. Actually, even they have 4 pre-trained tasks, they group into 3 types. The first one is a deep tech prediction, and then they have the DCD, that is the code related denoising, and they have these comments related denoising and the review comment generation, and they choose they see what's the result after you remove one type of this pre-trained task, and showing that every pre-trained task is important, because when you have all pre-trained tasks, your scores are highest. Yeah.
Oh, really? But the precision is higher in -DC, right?
You can see the recall is also higher than.
So they've scored, okay, F1 scored higher.
Yeah, accuracy is also higher.
All right, but F1 is the change is, for example, -CMT, and the reductions of the F1 is the minimal, right?
Yes.
So which means that with or without training with the tasks, so the performance would be still the same, right?
Yes,
so just so which means that there's no favor at all, just like Dr. Xiaoyan mentioned.
Yeah.
Okay, let's move on.
And lastly, they talk about the influence of multilingual data sets. They consider the Java, C#, and Ruby. So they pre-train and fine-tune with multiple languages, or only the Java data set, and they compare the scores. And if you use single, then your accuracy and F1 will drop.
Okay.
That's it. Then the last page. So this is a review-based task model, and they really talk about the related works in machine learning. And I summarize this. They have many.
Sorry, so you summarize yourself.
From their text, they
Okay.
basically list down all of the pre-trained models popular used, and they also talk about what are the common scenarios for the automated code review. For example, they have models to recommend reviewers, or you have models to do the code refinements or do the comments. And then lastly, they talk about the current data set, and their data set they say is the largest. Yeah.
All right. So, any questions for the work? Yeah, I think Jinglian make a very excellent preparations, and we have very hot discussions in this session. All right, so yeah, I think this work is trying to build some kind of more kind of foundational models, and once this model has been proposed, maybe this paper has been rejected by some NLP paper, but definitely be appreciated by the SE community. If possible, they will build a foundations, if we want to have this BERT-like model for code difference, this is almost the baselines we cannot avoid, right? All right, but anyway, so the idea here seems to be very straight for me. And also what concerns me is that first, the blue score, it almost be a common sense that a blue score may not be reliable, but people have no choice but to use it. Maybe we can, I'm not sure whether it's possible, we can avoid this blue score and provide the other, just like the authors do. They find the people, they have some qualitative studies to see whether the comments generated or the code generated is reasonable, right? This is one point. And second point, that is better for us to use this model by ourselves, especially if we want to not just into the code, but also the code change. So this is very important. Yeah, so
I read a paper before related to the blue score. They study a lot how the existing blue score variant perform in SE related task. Yeah, but I little bit forgot the conclusion. It seems there might be a better version, but I'm not sure.
There must be a better matrix than blue score to evaluate.
Yeah, their conclusion, right? I remember the conclusion looks like this.
Especially if we look into the comments, maybe the blue score. So you mean the blue score for code or the blue score for the natural language?
Code, because I read this paper in software engineering conference. During my survey.
Yeah. But you can see this for the second task is about the comments generation. In this way, in this case, we may still using the blue score, right? Because it is almost like common sense. Even if we want to invent some new metrics, the blue score is something we cannot avoid.
Yeah, but I mean there are better version blue score.
Yeah, that's great. And also maybe in the future, especially if we look into the comment generation, we can provide the generated text while provides using the user studies to further justify whether the code, the generated comments is good or not.
I have a question. If the second task performs that bad, when it means that actually the pre-trained model didn't learn a lot from this specific pre-trained task?
I guess yes. So maybe Jinglian, you are the one who read the papers. What's your opinion?
Yes.
Because we are totally the same, but the ablation study shows that without this, it seems just 1%. I mean,
no, 0.1. 0.1.
Okay.
I think because maybe when you comment, it need more background knowledge. You need to see why it is wrong, because the same code maybe in some situations it's right, but for some others it's wrong, and there is no.
I agree. So just like given an arbitrary piece of code, we want to use machine learning model to predict whether it's buggy. So it is almost nonsense, right? Exactly the same piece of code. If we put into one project, it is almost like a feature, and it's also possible that we put into another project, it is a bug. It fully depends on the specification. So here, I think it is more like information volume. So just look into a code change, whether it is enough for us to say it is of good quality. For example, if we given code, we change plus into minus, and if we add if conditions, and how could we, without any background, and how do we make any comments, even from a human point of view? It is extremely hard, right?
Oh, and it's like other than give comments, it's also giving suggestion, like a solution. And
because it appears in training data, right? It appears in training data, but let's think in a more general way. So given an arbitrary code change, for example, we change plus into minus, we add an if conditions, we remove a while loop. So how could we say that it's how could we say it is sufficient on whether we are informative enough to say it is of good quality, or whether we're informative enough to provide advice? It is very hard for a human, right? So if the human cannot do that, how could the model to justify they want to provide this kind of advice? So this is from my perspective. In this case, I'm not surprised that the model have a low performance on the comment generation. And for those who have correct comments, it's usually looking to some certain patterns, just like if we want to remove log4j's, if we want to modify the log level from log4j, so it is very common to say we cannot lower the level of debugging, we cannot lower the level of information generation. So this is very common patterns. Without any context, without any background, it is sufficient for us to make such a suggestion. But I think the majority of the code is basically a project specific, which means that an arbitrary modifications cannot give us enough information to provide any additional advice, unless we have the background knowledge of the project. Yeah, but anyways, this is a very interesting papers, and it is still kind of eye-opening. So we know that we now have a model on code difference instead of just the code text. So, but in the future, if we want to do some relevant work, and this is almost like a baseline and the backbone we cannot avoid. All right, so is there any other questions? So I think there are several PhD students haven't tried to raise your questions. So do you have any question to Jinglian? Or Mengyue, do you have any questions for Jinglian?
No.
Okay, so it's better for you to. So I think for this paper reading session, we serve several goals. The first is that if we just want to read the paper, not knowledges, reading paper is just enough, right? But so many people are getting together and we have hot discussions, we have debate. So in this case, I encourage us to take a good opportunity to involve into discussion instead of just reading the paper, getting the knowledges. And also it's good for us to raise a question, because in the follow-up research, raising good questions is very important, especially if you want to be a faculty job, want to have a faculty job in the worldwide. All right, so if there's no more questions, let's call it a day. And thanks, Jinglian, for the great preparation. Okay, bye everyone.